All right, let's get started, if you don't mind. Thank you for attending this. My name is Mark Botsford. I'm the district manager with the Metro Group or Water Treatment Company. And our mission today, Jason Horn is sitting here helping me out. He'll be my IT guy because I'm a little IT illiterate. But our mission today is to kind of help you understand the importance of the boilers in your operations. Does everyone here have a boiler or looking at having a boiler? Wondrous. You're in the right area. We're going to try to take some of the mystery out of it and provide some detail for you as you're crafting your products, because much of what we do is chemistry, and you guys are certainly involved with chemistry in one way, shape, or form in your processes. So, next slide. Okay, you're way ahead. Okay, our mission is, there's chemistry involved, like I say, and we want to demystify it. Many of you guys are not water treaters. We don't anticipate making you a water treater today. We just want you to understand the importance of treating the water and what that can mean to your operations, short-term and long-term. Most of you started out your business career this being a hobby. You're doing it in your home, either in your basement, your garage, someplace like that, and you were just making batches and having fun for the most part, I assume. And things led to you wanted to get bigger and better, and that's a great concept. But along with that comes the issue of equipment, and there's a lot of capital expenditures that are involved with that. And our intention today is to let you understand that there are ways that you can maintain the quality of the equipment you have that last for a long time, and to be reproducible in what you're doing as you're crafting your various beers. So our desire is to really to look at water treatment as more as a return on an investment of some sort, and then you're going to see the fruits of that labor down the road. When you're taking a look at your operating expenditures, there's a lot of things that are in that fold. There is the cost of fuel. That's 3/4 of your expense. There's labor, there's the equipment depreciation. And one of the things that comes up is chemistry. And chemistry is looked at a lot because it's one of the things that you can see. You see the chemistry coming in, you see the service person coming in, and it's an expense, but it's really a lower part of that expense, and we really want you to think of this as being an investment. So I'll look at that, and this just gives you an idea. This is a chart that has been around for many, many, many years, just showing the various costs that you would incur in that. Now, when we take a look at boilers, they can be a little bit intimidating. I mean, they're a pressure vessel. Many of you have not dealt with that, and the whole concept here is to just keep it simple. The KISS principles: water in, steam out. And if you do it the right way, you're going to get a quality effluent every time. So that's what we're going to try to do today, is do that. Now this can be a little bit, again, it's like, oh my gosh, what the heck have I got here? This is a massive little operation. Well, basically all you've got is you've got water coming into your facility, you've got a softener. Hopefully you've got a softener. This is showing 2 softeners. Comes to a feed water tank. That's a vessel that collects everything that is going to be going to the boiler. It heats that water up so that you don't have your boiler dancing across your mechanical room because of thermal shock and things like that. You've got boilers, and then you've got a return. You've got chemistries that you can add, and we'll talk a little bit about that. But this is just a little bit of a schematic to show you the systems that we're concerned ourselves with. Next slide. You've got a lot of different issues within the brewing industry, and we're going to look at each one of these individually. But you've got lack of pre-treatment. We'll talk about what you can do as far as helping yourself out. We've got lack of understanding of the boiler water treatment. Many of you guys, like I said, are not water treaters. Don't want you to be. We want you to understand what you should be having making sure that you've got a quality program in place so that your equipment runs properly. One of the things that we see a lot of times is improper operation of your boilers. You've got to make sure that we treat these things with some respect. They are a vessel that is pressurized, so we'll talk a little bit about that. We'll talk about your concerns and your issues that you have because of intermittent use. Many of you are not using a boiler 24/7. You're shooting the boiler up, running it, doing your batch, doing your kettles, things like that. You may shut it down and may not be run for 2, 3, 4, 5, maybe a week. Who knows? And during that time, there are things that are occurring in that boiler that, if you're not prepared to address them, can cause serious issues for you. And then there's inadequate control. Again, many times we see where you've got a program in place but you're not maintaining it properly, and you can have all the best chemistry in the world, you can have the best representation in the world, but we need buy-in from you and your people to make sure that you have the control that we need, because if we have that control and you've got the products and you've got the support, it will work. It works wonderfully. So we're going to go through each one of these individually, okay? The first one's going to be lack of treatment. Next slide, please. Lack of treatment, softeners. Lack of pre-treatment, excuse me, softeners. You guys have softeners in your plants at all? You notice? Okay. You may have them in your process side, and you also use that on your mechanical side. We want to get rid of any scale and calcium that is in that water, because as you heat water, scale, calcium, magnesium have an inverse proportion, inverse relationship with temperature. As you elevate the temperature, their solubility goes down, and they'll scale. And scale is an insulating factor. And when you're doing your processing, you don't want to have an issue where you're not getting the heating that you expect for the process that you're using for your beer making process. So we'll take a look at that. It limits the scale formation. We also add some chemistry to kind of polish that off. But a softener is the best thing that's happened to water treatment since I've been in the business for 40 years. There is. Everyone's got little different takes on this, a little take on that as far as polymers are concerned. But softening is wonderful, so please do that. The second thing about pre-treatment we're going to talk about is on your, next slide please. Oh, excuse me, before I get to that. Why is scale an issue to me? Well, the scale is an issue to you because this slide will show you in the brown top slide is normal scale. We've got scale with some iron, scale with a little bit more iron, and scale with some silica. We're from Rochester. We don't have a lot of silica in our water, but if silica is in your water, it's a major issue. It's a pain in the neck. Typically, we see scales with iron in them, and if you have scale with iron in it on your heat transfer surfaces, you can see a reduction in your efficiencies by 8%. Significant dollar. I don't know what you spend on your energy, but if you have a fuel bill of $50,000 and you're going to say have 8% efficiency loss, you've just wasted $4,000. You've spent $4,000 more than you should. And many times you'll find that the water treatment programs we're talking about are less than $4,000. So that's your return on your investment. We try to help you with that. But you can see the scale is a real issue with you, and we don't want to see it. And if you've got a properly operating softener, you should not see that at all. The next thing we have to talk about is feed water temperature. Feed water temperature is critical to us because cold water has a lot of oxygen in it. And as you heat the water, the oxygen gets very, very excited. And if the oxygen gets very, very excited and it's not vented properly, it's going to look for some place to go high. And it's going to burrow into the steel within your boilers and your feed water tank. And you'll get holes, and you'll have a sprinkler system in a place you don't want to sprinkle it. So we have to watch it very closely. We elevate the temperature without cavitating the ponds. Most of you probably do not have deaerators. You've got feed water tanks. Yeah, they're not under pressure, and that's not unusual. Again, a deaerator does a better job of liberating the oxygen out of the water. That does most of the mechanical work, 99.9% of it, but we still need to polish it off. So we'll add a little something to that, and we'll get into that a little bit later. But we want to make sure that the temperatures are where they need to be, and you know that you're okay as long as you have a feed water tank pumping water to your boiler and it's not cavitating. It's not making all kinds of noises on you, and that happens. You start losing impellers and stuff like that. You want to make sure that the temperature is at as high as it can be without cavitating. Many times you'll see in bigger operations, you'll see the feed water tank maybe in the air. It's the next floor up. And that's because you got to have head pressures and all that to make sure that the pumps don't cavitate and deliver the water the way it needs to be done into the boiler. So that's down the road when you get to be a bigger brewer. Next slide, please. This slide here is going to show you that, I wish I don't have my marker, but there's various lines. I apologize for the being a little bit convoluted as far as the slide is concerned. But the arrow there shows 210 degrees. Really, these deaerator or these feed water tanks that you have are usually maybe 170, 180 degrees. And I'll tell you that at 180 degrees, water still has a lot of oxygen in it. It has a couple ppm. And a couple ppm of oxygen can ruin a boiler. I'll tell you that back in 1980, probably 86, I started in this 82, so probably 86. I was at a boiler opening, and it looked great. Clean as clean could be. But they didn't have the moisture out of it. They still had oxygen in it. And 4 days later, we went by and back, and the boiler was pitted. The tubes were pitted. Oxygen is very, very aggressive, so please do everything you can. And there are things that you can do, and if you are treating your boiler, your water treater should be able to help you with ways you can store a boiler, wet and dry, and we'll talk a little bit about that later on. But lean on your water treater. If you don't have a water treater that's doing that, you should find one. The thing about this is that when we talked in the last slide about the return, or the feed water tank, we've got return coming back. You want to have condensate coming back. You want to return all that condensate you possibly can from your processes. That has valuable BTUs in it, incredible amount of energy there. And if you don't return that, you're just throwing a lot of energy down the drain. So you want to bring that back and save those BTUs all you can. Next slide, please. Now, how aggressive can oxygen be? If you take a look at what's going on, water at 50 degrees has a certain amount of oxygen in it. For every 18 degrees in Fahrenheit, you elevate that temperature, the oxygen gets twice as aggressive. You increase another 18 degrees, it'll get more aggressive. You do another 18 degrees, you get more aggressive. If you get 212 degrees with that water that had a couple ppm of oxygen in it, maybe 3 or 4 ppm of oxygen in it, that oxygen's looking for someplace to go. And if it's 512 times more active, and it's moving around, it's looking for a place to leave. And if you don't have a vent, if you don't have a method of mechanically removing that or chemically removing it, if you don't have any other method, which would be awful, it's going to pit. And the thing in our industry is that if you have corrosion, if you have pitting, we can't help you out very much with replacing that. And that's a big job. If you ever got to the point where you scale the boiler, we might be able to help you out with cleaning that with various chemistries. But we can't put metal back on where metal was taken away from. And if you start getting a boiler that leaks, either in the tubes or at the tube sheet, things like that, it's a very, very costly exercise, and one that does not need to be done if you're treating the water properly. Okay? Next slide, please. Any questions on that so far? Good. Well, we're going to talk about various things as far as properly treating water. And there's really 3 areas that we concern ourselves with. We want to make sure that we inhibit scale. We do not want to have any kind of calcium carbonate or anything like that laying down on hot heat transfer surfaces because of the insulating factor. We showed you that slide. We don't want to have any pitting occurring. We want to make sure we've got good oxygen scavenging. And then we want to look at condensate control as well. On the scale inhibition, there's a lot of different technology out there, and you can use various technologies. We tend to stay with polymers. What we do is we add a chemistry in there. The polymer does a number of things. The easiest way I can explain it to you is that the polymer will give everything negative charges. Negative charges repel each other. They don't come together. If they can't come together, they can't fall out of solution. If they stay repelled in there, we can blow that down through your surface blow, through your, and you also obviously do bottom blows, but we get rid of that stuff. Polymers also distort shapes. If you take a look at scale under a microscope, it's almost like a building block. It looks just like the cinder blocks on your house, with one layer on top of another on top of another. Polymers will give everything distorted shapes so they can't come together. If you're making a little bit of that, it's going to be like a house of cards. It'll be like balls. That's the best scenario I give you. But they don't come together and stick together, and they're very, very difficult to remove. So we treat with polymers to distort the shape, and then give everything a negative charge, and then we can remove that through proper blowdown, getting rid of those solids through your surface blow, bottom blow, things like that. So polymers are a way to go, but there are other chemistries out there. There's chelants out there that they're falling away. Phosphates are out there, they're falling away. Most of the companies now use polymers. We don't use phosphates as much anymore because phosphate is a precipitated type of treatment. It'll look for any kind of calcium, make a tricalcium phosphate precipitate, and that'll drop to the bottom of the water, and then you blow that down through your bottom blow. Not a lot of phosphate out there. The ones that are using phosphates for the most part are older Navy guys that have been in the business for 45 years, still out there. Sulfite, we want to maintain control of oxygen pitting. So we have a mechanical means. We've got a deaerator. We're running that properly. We've got the temperatures proper. We're ripping off a lot of the oxygen, but we still have some oxygen there. This equipment is not 100%. So we add a little bit of sulfite. Sulfite is SO3. Very readily available. Everybody's got it. You add sulfite, SO3. It looks for oxygen. Makes sulfate, SO4. And if it makes sulfate, SO4, you have scavenged that oxygen, you've tied that oxygen up, it's not going to be a problem to you anymore. And you measure in your boiler for sulfite. It's like an insurance policy. Most of the industry standards say you want 30 to 60 ppm of sulfite in there, so that if you have a little bit of a run of oxygen, you've got sulfite in there to scavenge that. I'm going to tell you probably want to go a little bit higher, and I'll tell you why that in a minute. So you need to have an oxygen scavenger in there. Sulfite is usually what's used. There's other things out there, but sulfite is usually the most economical, the easiest to use. It's available in powder or a liquid, and not a problem. Condensate treatment. When you make steam and it goes off into your vat and it's doing your tricks for you, you're looking for clean steam. Along with steam, which is H2O, you will get some CO2 going over, carbon dioxide. There's alkalinity in the water, and that in the pressure and the temperatures of the water, you'll make carbon dioxide. Well, carbon dioxide and water come together and form carbonic acid. Carbonic acid is what you see in a lot of condensate lines as the channeling, the grooving in the return lines. You may see that on the bottom. If you have that going on, it means that your condensate is low in pH. It's acidic. And we combat that by using an ambient. Very simple chemistry, but it will prevent carbonic acid from forming. You'll make a carboxylamine, tough tongue, and you'll know you have that if you have a pH above 7. We normally try to maintain pH between 7.5 and 8.5 on the condensate line, meaning that we have enough amine in the system to prevent corrosion, but we don't have so much amine in there that we're acting like a cleaner. If you think of a cleaner, most cleaners have a high pH, 9, and you get cleaning. You don't want to clean the condensate system. We're not interested in cleaning it. We just want to maintain the integrity of that metal that's mostly steel. So we throw a little bit of amine in it, not very much. You probably wouldn't use very much because most of your steam that you're making is coming back into that. You're not losing a whole lot of water. You have not probably a closed system, but pretty closed, you know. So we'll look at doing that. That's your treatments. That you want to make sure you've got good scale inhibition, good control of your pitting potential, corrosion due to the presence of oxygen, and then you want to maintain the condensate return line so that you don't have any failures there. And if you have a condensate line that is threaded, you'll see the failures in your condensate line at those threaded unions because that's where you have the thinnest wall. So if you've got any issues going on there, you'll see the leaking there. That's really just hitting the treetops as far as treatment is concerned, but that's what you want to have in your treatment. The next thing we're going to talk about is operation of the boiler. And you know, there's really three things there: you know, bringing the boiler online, what's happening while the boiler is online, and then how you take the boiler offline. Number one is when you bring the boiler on, you're probably rather excited because you want to get your kettles going and making this incredible product that you've envisioned and you're trying to consistently make. I'm going to tell you that the best way to bring a boiler on is bring it on slow. Don't just put your foot on the pedal and ramp her up hard because you're going to beat that boiler up. Everything needs to expand properly in that boiler. If you're ramping it up too fast, you're going to beat it up and it's going to fail on you. So bring the boiler up slowly. Follow your boiler manufacturer recommendations. We are not a boiler manufacturer, but I'm telling you that I have been a part of so many conversations where they had an issue that they didn't understand it. And they're looking for who they're going to blame. They're going to blame the water treater. And I say, this is not a water treatment problem. You don't blame your water treater. I want to help you out. Your water treater that you currently have, it's not his fault. It's more of a understanding of how to bring it up. Okay, so follow your manufacturer recommendations, follow them closely, and if you ever do run into problems, one of the things they'll look at is how are you bringing this thing up if you start seeing cracks and things like that. So now we've got the boiler up, we're running it perfectly well, everything's cool, we're making our product, and we got to control our chemistry. And there are certain things you can do to control your chemistry. It's critically important that you have soft water with just good operating softener, and you do have good control of your solids and whatnot, your dissolved solids in your boiler through bottom blowdowns and surface blowdowns. And we'll also get into one of the slides that's talking about testing. We'll talk about that in a minute. We're also going to talk about how critical blowdown can be as we get into a phenomenon called carryover. Well, now you've made your batch, everything's cool, now you're going to bring the boiler down. What do? Well, you got to make sure that, again, you bring the boiler down slowly, okay? And we're going to talk about, and I think in the next slide, is about what to maintain as far as residuals. Yeah. In the next slide, please. I know you got out of me. Yeah, I'm sorry. Okay. We want to talk about, in the literature, they'll talk about maintaining salt fight between 30 and 60 ppm. It's an insurance policy. It's like a $500,000 insurance policy, okay? And it works. And what happens is we've got some residual sulfite in there, so if we have any oxygen coming in, we've got sulfite there to help scavenge that oxygen so we don't get pitting. In your operations, typically you are on and off, on and off. For extended period of time, you're off. Then you come on for a short period of time. So what I would recommend is that you maintain your sulfites at 100 ppm minimum. Why? And I'd also recommend that you maintain at least 300 ppm of P alkalinity. Literature says 300 to 600, you go 300 to 800, 900. It gets into a situation where you get into foaming with alkalinity. You think of alkaline detergents, they start sudsing and all that. I'm going to tell you that if it was me and I was running the boilers, I would have at least 100 ppm of sulfite in there and at least 300 ppm of Alkalinity in there. The rest of it, it doesn't matter when you're offline. But the 100 ppm of sulfite will give you added insurance as that water cools and as oxygen gets back into the system. It's going to settle down. It may be for 2, 3, 4 days, maybe a week, your boiler's offline. But there's oxygen in there. And then all of a sudden you say, hey, ready to make a batch, let's go, let's ramp the boiler up. And when you start ramping that boiler up, that water in the boiler is cooler. And you're going to start ramping it up. And it's going to get that oxygen excited again. It's going to look for someplace to go. And initially in your boiler, it's kind of stuck in your vessel. If you have 100 ppm of sulfite in there and you get the oxygen in there, that sulfite's going to come down as it scavenges some oxygen, and you'll have better insurance to maintain control over that oxygen maybe in the system. So when you come back in a week, maybe you're at 40 ppm of sulfite. You're still okay. You still got insurance. When you get in trouble is when you do that test and you don't have any sulfite in it, or you have less than 10. Because really the test is really difficult to interpret under 5. You just want to have sulfite. So sulfite is very inexpensive, a couple bucks a pound. And most of the boilers that you guys have, it probably cost you $1 to throw in a bunch of sulfite every time you did that. That's a whole lot less than retubing a boiler or dealing with the mechanical issues there. So I would say, if you take nothing else out of you, when you're running your boilers, talk to your treater about elevating the sulfite up to 100 ppm. And he should tell you that it's going to help you with the times that you have in operation. Okay? What else do I want to tell you about this? I think I'm going to pass on that and go to the next slide. Here we're going to talk about chemistry levels being monitored. When you are doing your process, I mean, you have developed a flavor of beer, a product. And you know that you've got to put ABC in there and a little bit of XYZ and all your ingredients and all that. And you got to get all that in there. Now you start the cycling process, and in that cycling process, you know, you're evaporating the wort and all that kind of stuff, and you're looking at getting a certain alcohol content, you're looking at getting a certain taste, you're looking at getting the DMS evaporated away. All that stuff's going on well. And if you're doing this in a system that is reproducible because you've got the steam boiler working right, everything's cool. Maybe, I don't know, what is a typical evaporation cycle for you? I mean, in hours. I mean, when you're brewing in the kettle, hours. Okay. If you can't get what you need as far as temperature or things like that, and all of a sudden you've got to heat for longer, you could maybe get more reactions occurring in other parts of the process that could impact flavor or alcohol content or whatever parameter is. You just can't, and many times you have to, that batch isn't going to be right. The other thing that really gets into play here for you is carryover. Does anyone know what carryover is? Carryover is a thing where, and when you're steaming, and you are think of the boiler as a big old pot, okay, and you're bubbling away, okay, and when you get things bubbling away, you get the liquid phase changing to the vapor phase, okay, and it's got to pass through that water phase at the top, and then if you get too much garbage in there, too many solids. If you're not blowing down properly, that vapor, as it's passing from the liquid phase into the vapor phase, is going to pick up shit from that top layer. It's going to carry that over. So now you don't have pure steam going over, you've got part of your boiler water going over. Sometimes you can have this thing really percolate and really bubbling, and you'll see in your cycle pattern, usually you see a little bit of movement, okay? And that's cool, that's fine. If you start seeing these wild fluctuations, you're getting carryover. Sometimes we see where you've got machines, all of a sudden you're making steam, and then you open up your process and you're going to have steam, and you open up too fast and you get like an equilibrium change, and you get boiler water suck out. That can be carryover. You don't want that to occur in any of your systems, because that's going to impact significantly the quality of steam. That's going to put deposition on areas outside the boiler. In those areas, you're going to get pumps cavitated. It's going to be a mess. So you want to try to prevent carryover. Carryover is dangerous. It can affect your heat transfer, and it is something that, with proper treatment, can be controlled. Most boiler waters, treatments as well, have a little bit of an antifoam in there to prevent that foaming from occurring. Because we're asking you to put some alkalinity in. We don't want a lot of alkalinity. I just told you that I'm okay with higher alkalinity, and I am. Because most boilers treatments have an antifoam in there to prevent that from occurring. You just don't want carryover, because that'll just damage your product and get you to a point where, again, is the batch any good? So please avoid that. We're in inadequate control? Yeah, okay, good. Part of that whole thing is testing the water. And this is where it can get a little bit dicey, because a lot of people don't want to have another job, another task. But if you're going to be serious about maintaining control in the mechanical room of the boiler operations, there's certain things that we have to know. You have to know as on site. Test the softener. Is the softener running right? Producing proper hardness for it. If it's not, the water treater can do some site analysis and figure out what may be happening in that process. But you want soft water. If nothing else, you want soft water and good blowdown. Soft water coming in, can't scale. If I blow down right, I'm not going to have a whole lot of issues with any other conductivity. I just got to make sure my chemicals are okay. But I want to test the softener. I want to test the feed water. Make sure the feed water is of good quality. Feed water can tell me whether I've got a problem with my condensate lines. It can tell me whether I've got a problem with my softener. It can tell me whether, you can take a look at the temperature. Make sure the temperature is where you need it to be. The hotter the water, the better the water without cavitating the pumps. Many times we will put sulfite in the feed water. And the reason we put sulfite in the feed water, if we can, is because that feed water tank is usually lined as steel. Most tanks are not glass lined. If you've got a glass lined tank, good for you. But we can protect that internals of that feed water tank that has oxygen coming in with cold water, because that's where the soft water comes in. The cold ambient water comes in. You're heating that up, usually with a steam sparge. Usually your condensate may be just providing the heat that you need for it. Those are all the idiosyncrasies of every system. But you want it as hot as you can. But you want to make sure that the feed water quality is fine. When we get to the boiler, we want to make sure we have proper polymer in. Don't need too much polymer. Just need polymer in there to give everything a negative charge and everything repels each other. Keep it in solution. Keeps it in solution, we can get rid of it. We want to check for sulfite. Simple test. Make sure we've got a little bit of insurance for sulfite. We want to test alkalinity. We need all these reactions to occur, start here and go to here. The alkalinity helps us do that. It also makes sure that we're not in a corrosive state. So we have a little bit of alkalinity. Don't need a lot of alkalinity, we need alkalinity. We test the boiler for that. And if the numbers are telling us to do something, we can either increase bleed, decrease the blowdown, we can add whatever reagent or whatever chemistry we need based on the chemistry we've just done, but we're going to keep that in control. And then we're going to test the condensate and make sure that the pH is where we need it to be. We don't want too much pH because we don't want to be cleaning the system. We don't want too little pH because we're going to be corroding. On a pH between 7.5 and 8.5. And usually in your systems you're going to use probably one product, because most of your steam is going from mechanical here to the kettle here. It's not like you're going a half a mile out into a canvas. There are different amines that have different distribution ratios, different desires to be in the same phase. You want something that's going to be treating a short run. But if you have that going on, everything's cool. And when you have everything really, really cool, then you're going to record that information on a little log book on site, get a little diary going, so you know what you had in the past, and you also know what, if something's occurring, and you can go back and take a look at that. But you want to keep a log of that. And many places will give you what they call a water control chart. And a water control chart is going to say polymer level, 5 to 10 ppm is the control range. What to do if it's under 5, what to do if it's over 10. Sulfite level, 100 ppm plus. If it's 100 ppm or more, you don't really add product ABC. If it's less than 100 ppm, you might want to increase the feed of product ABC for your sulfites. Alkalinity, same thing. You have a range. What to do if it's above, what to do if it's below. Conductivity, if it's too high, increase bleed, blow down. If it's low, decrease. And all that does is allow anyone to go into there and just understand what the readings are and what to do in the event of this. So you don't have to be a rocket scientist. You can have a lot of different people doing it. The most important thing I'll tell you about testing, and I'm really, really big on this, is that you've got to do the procedures the same way, proper way. If it says add, take 50 mils of water, you take 50 mils of water. You don't take 52. If it says 3 drops of this, you're better off doing 3 drops of that. Just do the procedures the right way. Collect the sample the right way. If you're going to take the time to test a system, get a sample of water that is indicative of that system. If you're testing a feed water tank and the feed water tank is here and I have a valve here, I'm not going to take that first draw because that's been sitting in this pipe. It's not indicative of what's in the tank. Let them draw, get a good sample. You're going to take the time to sample water that's representative of that. If you're sampling a boiler, you have sample coolers on your boilers. Bring your samples. Wonderful. It's a safety thing, but it also gives you a really good representative sample. Let that run for a little bit. Get that in there. Get a sample out of the boiler. Okay? Because what's going to happen is you're going to do this test, and if you haven't got a representative sample, you got some silly numbers, you're going to say, shoot, I got to do the test again. You just wasted your time, or you're going to make a determination using data that doesn't mean a hill of beans. So get a representative sample. Okay? And then do what the report says. The other part of this is that if you have good control, you're going to be able to save money. You're putting money up front, but you're going to save significant dollars because the equipment will last longer. It will produce consistent steam, allow you to have consistency in your operations, and you'll never have to spend the money down the road again and go through that whole loop. Please pay attention to that. Next slide, please. I think I'm done. Questions? Probably confused some people. I hope not. I tried to make it as simple as I can. There is a lot to it, but I just tried to hit the treetops on this. You got any questions? Anything that I can help you out with? Yes, sir.
Here's another quick question. When I'm doing my boiler blowdown, it is bringing cold water in from and bringing it into heat tank, right? So that water is getting heat up because you're going to go over to the boiler when I'm doing the blowdown. That makes sense. Is that causing any issues with oxygen right there? Or?
It could. It could. I mean, when you blow down, now you're blowing it down manually. I would recommend that when you're doing your blowdowns, you do them for short periods more often. Don't blow the boiler down the sight glass and then have it refill all the way up. If you need to blow down the boiler more, I desire to blow it down for 5 seconds and do it again in an hour instead of blowing it down for 30 seconds then and there and having a big slug of it. You know, do that method, and you will avoid some of that because the feed water tank can probably keep up with that slower or that shorter duration. Okay, but yeah, you don't want to put cold water in. Other questions? All right, we got a couple things here. Number one is that we've got if you want to enter into our drawing, we're going to have a drawing. So everyone here, Jason, you want to hand those out? You probably should hand those out. If you don't have a business card, you can put your name on a slip here, and we're going to draw out for a gift card for you guys spending time with us. We want you to go and have a great time with the rest of the convention. This is a great time. I mean, this is a novel concept. On a lot of these, I've never had beer at 9 o'clock in the morning at the opening address, and that's something I'm carrying with me going forward. So, but we want you to have a good time, and if you've got any questions, we're at booth 64 in the conference room, in the exhibit room, and the last slide is going to give you our contact information when we get a hold of us. But if you want to fill these things out, we're going to do a drawing right now. We're going to give out $100, $100 gift card. So if you want to hand those out, yeah. Here's some pens. Someone has this pen. Have a pen by somebody. Give me the pen. SLA. There. Yeah, get in there. If you don't have a business card, then fill out one of our papers. All we're asking for there is your name and your address and your company name so that we know who we're going to be contacting. But